So, moving on to the technology. I'll show you a little bit about what an air scrubber is and how an energy recovery system is, but I think it's first important to say, well, how do we go about this? In other words, yes, we built air scrubbers. So you can see this picture here. We've got a farm. It's an American farm. It has these big fans out the end. Basically, the way we climatize a pig and a chicken barn is we, on the whole, suck air into the building. So we create a negative pressure and we blow it out the end. And depending on what time of the year it is, if it's in the summer, obviously we're having to push a lot more air through the house to keep the animals cool, because of course you've got a lot of animals in there producing a lot of heat, and we need to keep them in a comfortable zone. So the idea is that we're pulling air through the building and pushing it out the other side. And we need to clean that because there's considerable volumes of air. Again, if we look at a chicken house in the UK, in the middle of the summer at peak, we're probably generating about 400 to 450,000 cubic meters of air emission an hour, which is quite considerable. So we first of all need to determine how we're going to address that to achieve some level of emission reduction, okay? And there are standards, there are protocols, there are rules. We've actually been doing this for 20, 30 years. And there is a document that's published centrally from Europe called the BAT. Again, this is another document I can share with you afterwards if you want it. It's the best available techniques, and this covers the broad spectrum of farm management, everything from climate systems, feed management, manure management, everything to do with farming is in this document, and it's a guideline. It's a protocol that farmers use to do the best they can in terms of farming pigs, chickens, cows, etc. And in that document, there's a chapter on what they call end-of-pipe emissions and or abatement. And the idea behind that is that that there are protocols, tried and tested methods by which we test technology and its effectiveness to reduce those emissions. And you'll see here's some examples. The type of scrubber I'm talking about today is a single stage air scrubber. There are what they call multi-stage scrubbers, where not only are we cleaning, we're cleaning in several steps. So we may have a chemical process, we may have a biological process, we may have a water process. That would tend to be a more complicated scrubber, but on the whole, what the industry is trying to do is to make air scrubbing simple so that it's easy for farmers to manage, because if you don't manage it well and you don't maintain it well, then it's not very effective. So just as an example here, the BAT will lean on tried and tested protocols, and what they suggest is that farmers should be looking to introduce end-of-pipe reductions based on official protocols, and they will range, for example, with ammonia management, a reduction between 70 to 90%, odor reduction around 30 to 40%, dust, which also has an impact on odor, around 80 to 90%, okay? The protocols that they are suggesting is basically based around centralized extraction of air. So like we were seeing in that picture, all the fans are at the end, and it's a fairly easy process to stick a technology on the end of a barn and clean all the air that's coming out of those fans, right? It also alludes to the fact that retrofitting old buildings where maybe there's extraction points all over it can become challenging, because of course you don't have that central point of extraction management. But, and this is the important point, the protocols on the whole lean towards the idea of reduction based on the maximum air volumes produced at any point in the year. So going back to what I was saying in terms of a chicken house, they are looking at how they can reduce percentage of air volumes based on the maximum. And if that is 450,000 cubic meters an hour, that's a lot of air to have to deal with. Okay. And if we look at the graph on the right, and the point I'm making here is that's all well and good, but as you'll see, as we go up this graph, let's take the 2 ppm zone, which is where we're talking, you know, between the 70 and 90% odor reduction, ammonia reduction. As we increase the capacity, the overall impact is less, okay? So it gets a little bit technical, but I hope I explain it well. So in fact, what happens is the more money you throw at the problem, the less effect it has. You try and explain. If they're asking us to clean 70% of the air because some protocol insists on it, and the authorities are reading are making rules based on the protocols, then based on this graph, we will have an overall emission reduction of around 70%, 75%, okay? If we were only cleaning 30% of this air, we would achieve just under 70%. So what I'm getting at is this scale here, which is proportion of air cleaned, is not only the level of technology you have to put in, but it's also a cost graph to the farmer, a big investment for little benefit. So the point I'm making on this screen is at the moment in the UK, because the rules stick very much to what is driven in the BAT, what is driven by the protocols, there's a big insistence at the moment that we stick to this, which has quite a high financial impact on farming, because the overall benefit may be not that great compared to what you're investing. I'll park that thought for the moment because I'm going to come back to it later on when we talk about scaling up. I made the point here, 30% air cleaned is greater than 70% emission reduction, and more to the point that if we stick to these rigid rules in air scrubbing, then we will only ever have a 5% growth a year, because farmers will only ever invest in it if they're forced to. And then when we get to 2030, and we're looking at this 16% target that the government is going to set, we'll be in blind panic, because basically we'll have only upgraded X number of buildings, and we should have upgraded at least 30 times more than that. So the point I'm making is we may have to look at this slightly differently.